we're going to go on and look at the last part of 2.32. So what we looked at yesterday was given information, either the vertex in focus or vertex in directrix, and we saw one with the focus in directrix, we found the equation of the parabola. Now we're going to be going the other direction. We're given the equation of the parabola, and we want to find the vertex, focus, axis of symmetry, and the, I think that's it, vertex, focus, directrix, and axis of symmetry. So we're going the other direction. Now, for these here, it's kind of, it will tell us exactly which equation it is, because it's either going to be written as y equals or x equals. It's just going to tell us. Now, what we need to do is find the values of h, k, and p. Because if I can find the values of h, k, and p, then I can tell what the vertex, focus, directrix, and axis of symmetry is. So what would our value of h be? Positive 3. Matching up the h's. Now k would be 2. And p would be? Well, we don't know, but the 1 over 4p would match up with the 1/8. So what we can do is we can set up the fact that 1 over 4p is equal to 1/8 and solve for the value of p. Now the first thing we can do in solving for the value of p is to multiply both sides by 4p. Because this 4p and 4p would cancel, telling us 1 is equal to, well, 4p over 8. Well, 4/8 can be simplified to what? 1/2, so we can say p over 2. Now what can we do next? We can multiply both sides by 2 because the 2 and 2 here would cancel, telling us that p is equal to 2. Any questions on how we found the value of p? Okay. Now that we found the values of h, k, and p, we can actually get the vertex, focus, directrix, and axis of symmetry. Now the vertex is the point h, comma, k. Well, what did we say was the value of h? And k is 2. So what we get is the point 3, 2. So that would be the vertex. We don't have to do much for that there. Now the focus is going to be the point what? H, comma, k plus p. Well, actually, erase half of h. Because h is just 3. Now, k plus p would be 2 plus 2, which is 4. The directrix is our y equals, well, this would be our k minus p, which would be 2 minus 2, which is 0. And last but not least is the axis of symmetry, which would be x is equal to 3, x is equal to h. And that's it. That's all we have to do. Because once we find the values of h, k, and p, we plug them into each one of the 4 to get our answers. All right, let's look at the next one. So y equals -1/4 parentheses y plus, or x plus 2 close parentheses squared plus 1. So looking at this here, what is the value of h? -2, because inside the parentheses it's normally x minus h, and since we have plus, it means h has to be a negative value. What would k be? 1. Now we do need to find the value of p. Well, we can see that 1/4p is going to equal what? -1/4. So the first thing we can do is what? Multiply both sides by 4p. Well, 4p and 4p will cancel on the left-hand side, which gives us 1 is equal to. Well, I meant the 4 and 4 here would cancel, leaving us with -p. Or really that p is equal to -1. Because if -p is equal to 1, then positive p would equal -1. Any questions on this here? Okay. Vertex is the point hk. Well, what's our h and k? -2, 1. The focus again is h, k plus p. So we'll still have -2, comma. Well, we have what? 1 plus -1. So the focus is -2, 0. The directrix is going to be our y is equal to k minus p, which would be 1 minus -1. 2, because the negative and negative make a positive. So the directrix would be y equals 2. And last but not least, the axis of symmetry would be x is equal to -2. That's it. Questions on this here? Are you ready for the next one? Okay. So this one here is x equals, so x equals 1/4p, parentheses y minus k squared plus h. The value of h would be 1. Because whenever we do have x equals, the number that's being added or subtracted inside the parentheses is k. H is on the outside. So we do need to pay attention to that h and k got flipped. So h would be 1, which means k is 3. And then we would need to find p. Does anybody have a guess at what p will be? If not, that's fine. Exactly. So if we solve this here, we're going to set what? 1/4p equal to 1/16. Well, at this point here, we can multiply both sides by 4p. 4p and 4p will cancel out, leaving us with 1 is equal to 4p/16. Well, 4/16 is the same as p/4. So we multiply both sides by 4, telling us that p is equal to 4. Any questions on how we found the value of p? So this time the value of p was 4, right? And we got 1/16. What was p last time? -1, right? Well, P was -1, and this was -1/4, right? The value got a little bit bigger. What's interesting, and this is just an odd thought I had earlier, really if that value of P is getting smaller, closer to 0, it's going to work out that the fraction, or the number in front of the parentheses, is going to get bigger. It's going to get bigger. But as we saw here, since P got bigger, it went from 1 to 4. What happened to the fraction? It got smaller, didn't it? So now that's not going to tell you what the exact value of P is. But if the number, so here 1/16, is that bigger or smaller than 1/4? Smaller, isn't it? So we expect the value of P to be a whole number, or something bigger than 4, or bigger than 1. Because once we start getting smaller numbers like 1/4, well, it turned out to be 1. And actually the number as a whole got bigger. But if that's confusing, don't even worry about it. Let's look at the vertex. Well, the vertex is 1, 3, H, K. The focus is what? H plus 3, P, K. Well, H is 1, P is 4. 1 plus 4 is 5, yes. The directrix is going to be X equals H minus P. 1 minus 4 would be -3. And the axis of symmetry is going to be Y equals 3. And that's it. Any questions on any of this here? Be ready for the next one. All right. We kind of got the feel. I think y'all got the hang of identifying H, K, and P. So H would be what? -3. K would be, and we'll need to find P. So our 1/4P would equal what? Exactly. 1. Because the 1/4P's location is in front of those parentheses squared. Do we have a number specifically written there? No. So it's understood to be 1. If a number is not written in front of a variable or parentheses, it's understood to be 1. So we can do what? We can multiply both sides by 4P. 4P and 4P will cancel, telling me 1 is equal to, well, 4P. At this point here, we would divide both sides by 4, telling me P is equal to 1/4. Okay. What would the vertex be? -3, -5. Now the focus is going to be H, K plus P. So we'll have -3. Now, K plus P is going to be what? -5 plus 1/4. So we can say -4 and 3/4. Or we can say -4 Or we could say negative 4.75. Are all those the exact same number? Because 1 3/4 is 0.75, yes? So we can see that negative 4 3/4 and negative 4.75 are the same. Well, 19/4, because if it was 20/4, 20 divided by 4 is 5. We just have one less than it, so it would be the same thing. So Jesse, which one do you want? 4 3/4? Yeah. I will take any of them. As long as it's the exact same number, I will take any version of it. The only things I will not take is if we have a fraction in a fraction or a decimal inside of a fraction. If we have those mixed, I'm just going to mark it wrong, okay? Now, all of these here do work because negative 4 3/4, there's not a fraction in a fraction. We don't have a decimal in a fraction. We don't have those mixed. I'll take any one of those three. You just need to pick which one you want to use. Now, the directrix is going to be y equals k minus p. So 5 minus 1/4. Well, that'd be negative 5 1/4. Or negative 21/4, or negative 5.25. Now, normally for equations, we don't really use mixed numbers, but there's nothing wrong with it. At least I don't find anything wrong with it. So, and last but not least is the axis of symmetry, which would be x is equal to. That's it. That's it. That's all there is to this. Questions on this here? So there are, I believe, two more, 45 and 46, yes? Or do y'all, is there one of those that you want to look at, or do y'all feel good with these here? Or good with these here? All right. Well, if that is the case, I will give your homework assignment.